Yeah, hi. Good morning. So, first introduction of myself is that I'm Abhirup Dey, and I completed my master's in 2019, and after that I started my internship in Robert Bosch, and there I joined as a cloud engineer. So since then I was working in DevOps, cloud part, and little bit of data part there, and then I converted into permanent employee, and then I started working into DevOps, and side by side I started learning data engineering side. So after that, I joined in Accenture as a data engineer, and there I was working in ETL pipeline creation. I learned Databricks, Pyspark, and all these relevant things in Azure. And currently, I'm working in Fisker as a data engineer, and I'm mostly like working on the Airflow part, and also a few of data engineering, like Azure data engineering part I'm working on currently.
Okay. So can you tell me the current project that you're working on?
So basically, my work is related to like data scientists. They create. So it's basically ML ops. It's not not ETL pipelines creation. So mostly what I do is like data scientists creates their own much machine learning models, and I deploy them. I create pipelines in Airflow to deploy those models into the virtual environment, like staging and dev or production.
Okay.
So that's the yeah.
And what are the
So it's
programming languages that you have worked on?
Yeah, mostly I'm using Python, SQL, and for Airflow, yeah, mostly it's Python.
Okay. Have you worked on PySpark or any
Yes, I
other?
have. I have worked in previous Accenture. I have worked on Pyspark. Yes.
Okay. So also I can see that you have worked on Azure. So can you just tell me like what are the services and what was the end-to-end flow like? How have you utilized those services?
Yeah, sure. So for Azure, like mostly for ETL pipeline creation, I have used ADF, Azure Data Factory. So I was creating dynamic ETL pipelines there, and I mean, including all those variable things and everything. And I was utilizing like Key Vault to store all these like credential parts and everything. And then Azure Databricks. So I used to integrate the Azure Databricks inside the ETL pipeline in ADF and create some dynamic programming inside the Databricks pipeline. So what we had in the Databricks notebook that in the customer side, they want some dynamic notebook means that they used to input some data in the notebook itself. We used to use like dbutils.widgets into that. And from there, the data used to be getting generated in the Databricks notebook. And then we used to publish the output into the data mart or sometimes in Delta Lake, where we
Okay.
wanted.
Okay. What is the difference between a Delta Lake and a data lake?
So data lake and Delta Lake is basically same. So, but in the Delta Lake, we have some added advantage of like we have Unity catalog where we can add some quality checks and also like permissions to the different layer of data. Like we have silver layer, bronze layer, gold layer. So we can use the Unity catalog to add that advantage into that data lake.
Okay. So what is the exact use of Unity Catalog, as you mentioned? What is the exact use? Like, why was it needed in the first place?
So suppose there is in companies there are like let's say 10 people are working and not all of them are data engineers or all of them need to be getting access to the all layers of data. So suppose some data analysts are working in a project and they don't need to get access to the all like raw layer of data or maybe bronze or silver layer of data. They just need to get access to the clean part, like the gold layer of data. And let's say data engineers, they need to access the raw layer of data where all the transformation logics will be applied, all the cleaning parts will be done.
Mhm.
So that's why we need to separate all these things. So to like enterprise level software, we need to give access properly so people can work like there'll be more like data governance, we can say. So
Right,
data governance will be applied.
right. So have you worked on data profiling? Any tools or anything?
Not exactly.
Okay. Do you know what data profiling is?
No, I'm not sure.
Okay. Yeah, okay. Data profiling is basically like profiling the data. Profiling the data as in that when you get some data in the first place, let's say some sample data,
Mm.
you need what data profiling tools does is that it basically creates a generic script, okay, to just for example, let's say there are 5 columns, so it ensures that the values are correctly populated for those 5 columns. It shouldn't be like name column has some integer values. So
Mhm.
this mapping, this kind of thing, data profiling does. So you mentioned about data governance as well. Could you just take me like how you have implemented data governance in any of your projects using Unity Catalog or any other tool? Just an idea of what you understand by data governance.
Yeah, so yeah, in our project only we had Unity catalog implemented. So
Mm-hmm.
for that, what we used to do, like the raw data used to come from different sources. Sometimes it's coming from streaming data, sometimes from CSV files, sometimes from some random data used to be dropped by the developers. So from there, we used to collect all the data into a Delta Lake or maybe in ADLS location. And from there, we used to like transform the data, clean the data, and put it into a bronze layer. So,
Mm-hmm.
and then, I mean, all the layers has been separated in different locations, in different, sometimes in different virtual locations, or sometimes we used to create different files, or maybe sometimes in a different SQL database or maybe Delta Lake. So it was not fixed for every scenario. There are different requirements from the client side. So
Yeah,
based on
just
that, we
give
used
me
to,
an example of
hmm.
one such requirement.
Yeah. So let's assume that I mean there was an ex one project there was some files is to be dropped from SQL. Sorry, not SQL, in Excel sheet. So from the Excel sheet, used to collect the data, raw data, clean up the things, and then we used to apply the bronze. I mean, the cleaning and put it in the raw bronze layer.
Mm-hmm.
And after the bronze layer, we used to add some transformation logics based on the requirements and put it into the silver layer. So all these things, I mean, in bronze layer and silver layer, we has different type of permissions. So no one, I mean, not everyone is to have, able to access all these layers. And then is to go to the gold layer. And gold layer access was given to the high level employees, means that manager or maybe architect level employer or maybe senior data scientist. So yeah, so that's how it was divided into the different layers, and that's how data governance is to apply. And all these permissions and all these things were, I mean, credentials were stored in key vaults,
Mm-hmm.
and key vaults access was given to from Azure. This is like single
Okay.
sign.
Mm-hmm. Okay, so understood. So what I just want to understand from you is like, can you just tell me one or two or three maybe key features of the Unity catalog? Okay, like you said, data governance, that's perfectly fine. Anything apart from that? Because just one liners or some words would also do. Like some key features, if you would say, from what you have worked on, what do you understand that Unity catalog exactly offers?
So yeah, one is data governance, and another is like the storage level, means that some data needs not to be stored in a like there are different layers of storage. Like sometimes we don't only to store the historical data for last 30 days or maybe some last 1 year. So in raw level, I mean, in the bronze level, there we didn't need to apply this kind of like old data. I mean, sometimes we used to store it in a cold storage which needed not to be like accessed very frequently.
So
But
you
in the
can say
gold,
that access control as well.
yeah, access control and like storage level, like
Mhm.
cold storage or sometimes
Okay.
what I can say, like not which data was not able to access frequently, was not required to access frequently. So
Okay.
this kind of
So
things.
can we also say that it offers data lineage? Like it tracks the flow from the source to destination, exactly
Yeah,
how the data is coming. So basically it helps also in debugging, right? If there's any failure in between also in the pipelines, you can
yeah,
use that for debugging purpose as well. Okay.
that's true. Yeah.
Yeah. So, okay, just go through some of the more features. Like Unity Catalog has a vast display of features to offer. So just go through some of them more. Okay. All right. So, okay, one more thing I want to know is two things I want to know is how much data you are dealing with and what kind of data is it, what kind of files you are dealing with, and what kind of data as in historical or incremental, delta load, whatever. So just explain that.
Yeah. So data, first of all, data was not, it was not limited. Even for now, also data is not like fixed amount. So mostly it differs from 1 GB to 5 GB. Depends, sometimes more than even more than that.
1 GB to
So
5 GB in what time duration?
in daily basis.
Daily. Okay.
Yeah. And yeah, and also, uh, so can you please repeat the question again? Like,
Yeah, so the questions are number one is how much data you are dealing with. Number two, what kind of data? Is it history? Is it incremental? What kind
hmm,
of data is it? And number three is what kind of files are you getting from the source and what is the file that it's being transformed into?
yeah, sure. So yeah, mostly files were getting generated like CSV files, and we used to convert into Parquet format.
Mhm.
Basically, used to do that. And yeah, and uh,
What
all
kind of data?
data
History.
means like historical data, like let me recall it, because in current project we are not using such kind of things, but in my old project, historical data it used to come there on daily basis, and like it comes in the CSV file and convert into the Parquet format.
Okay. So you have been using Azure as well, right? So we have the Delta Lake thing. So we have the concept of Delta files as well. Like instead of Parquet
Right.
files, there's this new thing in the market for Azure, that is the Delta file. So have you had the chance to work on it?
Not exactly. Mostly it was like in Parquet format.
Parquet. Okay. All right. So can you tell me that what are the advantages of Parquet over other file formats? First of all, what kind of a file format is Parquet?
It's a like columnar based file format,
Yeah.
so it's
So
easier
how
for.
is it different and what advantages it has over row-based file formats or any other like CSV file format, whatever it is?
Yeah, so when the data amount is huge, like there are many columns. So when you're doing some aggregations or maybe filtering the data, so it is easier for when it's a columnar data. And also it has a compression technique. So that's why the Parquet files are more, the size are very low compared to other file formats. And for column data, if you're like looking for some kind of aggregation, so only we can take all those particular columns for the aggregation part. So rest of the columns will not be considered. So it will be more
Okay.
optimized.
Okay. Uh, do you know about predicate pushdown?
No, I don't remember. So I have heard
Okay.
about it.
Okay. Got it. Okay. So you have worked on Spark before, right?
Yes.
Okay. So what exactly like what are the things that you worked on Spark like RDD or data frame or data set?
Yeah. So yeah, I used to apply transformation logic using data frames.
Data
A lot of
frames.
things.
Okay.
Yeah, data is, I mean, DF SQLs, SQL DF, everything. Like
Mm.
SQL is to apply also, like data frame, Pyspark logics
Have
also.
you worked on data sets?
Yes, yes, it was there. Yeah.
Okay. So can you tell me, like, according to you, or as per your opinion, which is better, data set or data frame? Which is better for you to use and why?
So yeah, data set is basically is a like portion of the data which we can modify it or maybe we can view it. But the DF or data frame is basically stored in the memory. It's just a view of the data. It is temporarily stored in a particular session in the memory, so it's much more faster to access. We can query on the data, and also all these operations we are performing in the data frame, it will be happening inside the memory.
Mm-hmm.
And as like Spark has lazy transformation technique, so all these things will be like in the collect stage and data shuffling stage, it will be much more optimized if you're using data frame.
Okay. And what about, so there's a basic difference between data set and data frame. This
Uh,
is, can you recall like something related to type safety?
Not exactly. If you can explain me, it will be.
Okay. So you have used only Python or have you used any other programming language as well?
No, mostly Python, Python and SQL.
Okay. Okay. So do you
Scala,
know
I mean,
about, yeah, Scala, right? So do you know
mm,
about compile time safety and runtime type safety?
no, no, no.
Okay. So, okay. So when you write in Python, if you get any errors,
Mhm.
do you get it during compile time only or do you see it after you run the code?
So yeah, in notebooks only we're not doing some uh, coding in the notebook. So
Hmm.
whenever we run the code, after that we are getting the
Run. So that is runtime safety, right?
runtime. Yeah.
Okay. If you have used Scala, you will see that during compilation only, it will show you that it has error. So this is the difference. Like compile type safety gives you the error between during compile time only, runtime gives during runtime. So that's the basic difference between data set and data frame as well. Data frames do not give you compile time safety. You will see it after you run. But
Mhm.
data set, if you convert into a data set, you will get compile time safety. So this is a
Okay.
very basic key difference. Again, data frames have other advantages. So it depends on which one you want to use. Okay. Okay. So you mentioned about lazy evaluation of Spark. Can you explain that?
So lazy evaluation means that whenever I'm running some operations into the data, so there are wide transformations and narrow transformations. So
Mhm.
whenever there's an wide transformation, data is getting shuffling from one partition to another. And also like when you're doing some collect, we are like group by or maybe filtering the data. So those things can be like happening in white transformation. So that time, data needs to be shuffled in the like from one partition to another. So when a white transformations are happening, before that, when I mean the data transformation is happening in a particular partition, then all these things are like taken into a DAG or in a graph. All these things are not being compiled. So when you're collecting the data, or maybe we're applying some white transformation logic, or maybe collecting the data, then all these things will be happening in a DAG format in a simultaneously. So it will wait for that collect operation, or maybe some white transformation logic, then it will execute the operation. So that's why it's called lazy operation.
Okay. So basically, what is the conclusion? Like, why is it lazy? Like in one line, if you can say.
So lazy means like when it
Only
is
when it
not,
is triggered, it will run. Otherwise, it just
yeah,
stores in the DAG. Until and
right,
unless
right.
it's called, it does not do anything. Okay. So you mentioned about DAG. Do you know about lineage graph as well? What is
Mm.
lineage graph? Something related to RDDs.
Yeah, I mean, I have the concept, but I mean, I cannot recall it right now.
Okay. Have you worked on RDDs?
No, not exactly, but yeah, during some projects, like some Scala level project, I still work on it, but not in recent days, like in during the course material only I have worked.
Okay, okay. Okay, so when you, if you see there's a very famous problem, word count, which are
Hmm.
which is solved using RDD, right?
Hmm.
So you will see that there are new RDDs created in every step, right?
Right,
Like RDD1 is created from RDD based on some logic, then RDD3 is created. So
right.
what happens if, let's say, RDD3 is lost? Let someone deleted it. So
Mhm.
how can we, restore it back?
So basically, as if it's a lazy transformations, it's
Hmm?
not getting, I mean, it will again regenerate the data from the RDD2 or RDD1.
Right. So that is done using the lineage graph.
Mm-hmm.
That lineage graph is the thing which keeps a track of what is happening in every step. So basically, if RDD3 is lost, you get it from the lineage graph. Okay, these were the things that were applied, and RDD3 is created. So that's the importance of lineage graph. Okay. Okay. So you mentioned about narrow transformations and wide transformations. So can you name some of the transformations which you have used in your project, and how did you use it? Like, what was the use case, and why was it needed?
Yeah, I mean, there was a vast level of use cases as if there was lots of requirements is to come from the customer side. So
Mm-hmm.
yeah, I have used all like this group by filtering methods, also like aggregation, lots of the aggregations, joining, all this wide transformation is to use.
Okay. So when you use join,
Mm.
it incurs a lot of shuffling, right?
Right.
So how can we, uh, avoid that? I mean, we cannot avoid joining. Obviously, we no need to join two tables, but how can we avoid? I mean, lessen the shuffling before even joining the data frames. Like, what would
So
be your approach? Let's say I'm giving you a scenario. Let's say I have two data frames, two large data frames. Okay,
mm,
I cannot apply broadcast join because I do not
mm,
have a small one. So I
mm,
have two large data frames and I have to join them. That's the requirement. I have to join them because there are some common fields between them.
mm.
So if I join them, there will be a lot of shuffling. And I want to optimize that. In this scenario, I want to optimize that. So what will be your approach to solve this problem?
Yeah, first of all, I need to understand why we're joining the data. Like after joining, we'll be doing some operations into that full table, right?
Yes, we
Or
we we need the join. That is the client has said that it's a must. We will have to join.
mhm. Yeah, so we can do like all the operations which will be happening. I mean, we can sort all the parts. I mean, that will be easier if you're joining the tables. It will be already sorted, the both parts. And also
Sort
like
as in.
so different depends on our requirement that
Hmm.
after joining they'll be doing some operations, right? So maybe we are doing some aggregations or maybe some. So we can do that part in the before joining also.
Hmm.
After
Yes.
doing that, after doing the aggregation, then we can join. Then it will be like less shuffling.
Correct. So basically, we can filter the we can make it into a smaller subset of
Mm.
data, and then we can do the joining. So that will lessen the shuffling, right? Okay.
Right.
So have you worked on coalesce and repartition?
I have, yes.
Can you explain like what is the difference and what it does?
So repartition means like partitions can be increased or even decreased, but Coalesce only increase the partition. Only decrease the partition.
Mm-hmm.
So
Okay.
we are like merging two partitions as a Coalesce or something. Maybe we can join. I mean, join based on a particular criteria.
Mm-hmm.
Sorry, not join, but maybe aggregate based on a particular criteria in a particular column.
Okay. So let's say I have a requirement to decrease the number of partitions. Okay. So when
Mm.
the okay, coming back to another question, I mean the basic question, when you submit a Spark job, when the data frame is created, what happens after that? I mean, what happens after that, as in what is, what is the exact thing that happens after you submit the Spark job?
So first of all, there is a like uh, a plan gets created, means DAGs gets created, that how it will be executed in the background. Then it goes to the AQ, means adaptive query
Hmm.
execution, and it selects the most efficient method to execute
Hmm.
the data. And
But that
then
is in Spark. I think there's a version for it. For AQE, there's a version like some version and above like AQ is enabled. What I'm saying is that irrespective of the version of Spark. So, okay, what are partitions? First, tell me, what are partitions?
the partition is a partition of the data, or maybe based on some criteria, maybe based on some. Let's assume that we have some employee table. So based on employee number, we are partitioning the table. You can partition data horizontally or vertically, where
Mhm.
however it is visible. And yeah, so that's basically partition.
Yeah, that is based on the data. I'm
Hmm.
talking in terms of Spark. So Spark has these partitions, right? Spark partitions, you can say blocks also in Hadoop. So the
Hmm.
partitions as in like, let's say you have a 512 MB file, and
Hmm.
those are divided into how many?
120.
Four. Oh, yeah, 128, four blocks. So those blocks are partitions in Spark, right? So that is how it is created, because the partitions will be created and then the data will shuffle among the partitions. No. So
Hmm.
that is the basic. So that's what I'm saying. So when you submit the Spark job, the partitions are created. And then what you are saying is based on the data. The data, I mean, across the data, we will do the partitions, that this will go into this partition and this will go into this partition.
Hmm.
So my scenario is, when these partitions are created, when you submit the Spark job, number one, how are these partitions created? I mean, uh, what is the criteria for this to be decided, that how many partitions will be created? Number one. And number two is, let's say you have to decrease the number of partitions. Okay. So we have two options, Coalesce or repartition. So which one will be efficient for you, or which one would you choose, to Coalesce or repartition?
Uh, okay, so for how it is getting partition means, first of all, we can give the criteria that based on how it can partition. If we don't give the criteria, then it will create like hash partition. So it is
Mhm.
just generate some hash number, and based on that, it will be partition the data. And
Okay.
also each partition has maximum of 128 MB. So based on how much data is there, based on that, it will divide the partitions. So
Okay.
that, I mean, we can calculate the number of partitions based on that, the total number of data, I mean, amount of data. And yeah, Coalesce and repartition, I think I'll be for reducing the data. I think Coalesce will be more efficient, but I don't exactly remember the reason why. If you can explain that part.
So have you used Coalesce or repartition in real
I
time?
have I have used in recent one. So there was a
So which
criteria.
one did you use, Coalesce or
I used
repartition?
Coalesce I
Okay,
have
and
used.
why?
Because there was a particular scenario that I had to calculate some cumulative count for some data. So some repeating data was coming, and we used to calculate that how many times it is getting repeated.
Mm-hmm.
So for that, I used to coalesce the data. And
Okay.
yeah,
So
uh,
where does Coalesce happen? Does it happen in the driver memory or the executor?
it happens with the executor.
Correct. So, and where does repartition happen?
I'm not sure. Maybe it's driver.
It happens at the driver. So repartition,
Okay.
what does is it does a full shuffling at the driver level only. Okay.
Okay.
So repartition is the most effective when, let's say, when your data is divided, okay, you run
Mhm.
the Spark job, your data is divided. One particular partition is containing maximum of the data, let's say 90% of the data, and other partitions are empty, more or less, because 10% of data is just distributed. So in this case, there will be there will be a particular scenario. What is the name of that? One partition carrying more data and the other partitions being unevenly distributed. There's a name of this scenario. What is that?
Forgot actually. I actually studied that part. So it will actually, create some data. Means it will clone some data to like fill up the blank spaces, and then it will do the operations
Yes,
like forward.
salting technique.
Salting. Yeah, yeah, right.
Right. So what is, I want to know the name of the situation. And why is salting technique used in the first place?
Uh, so salting. Don't remember. If you can explain. I mean, that's why I mentioned
Okay, no
earlier that
problem.
I don't
So
have.
basically, when this scenario occurs, then what we have to do is we have to divide the data evenly across the partitions, right? Otherwise, what will happen? Based on that particular partition, if that is containing more data, that job will take a the job will take more time as well because it has to process through that data and others are just sitting empty. So we have to evenly distribute the data. So how can we do that? We can either use Coalesce or repartition. But in this case, if you see that one partition is creating more, it contains more data, don't you think that a full shuffling is needed? Because
Uh,
full shuffling, what will it do? It will again full shuffle the data and then it will divide across, evenly across the partitions. So
hmm.
this is the kind of scenario when you can use repartition.
Okay.
Okay.
Yeah.
And
I
Coalesce,
mean,
as you said, like if you want to merge some data, then
hmm.
Coalesce is a better option.
Yeah. So yeah, I mean, to be exact, like data skewness, to avoid data
Data
skewness.
skewness, yes.
Right. Yeah.
Okay. Okay. Yeah. So, yeah, more or less, we are covered with Spark. There, uh, just go through like the basic concepts of it. What happens in the backend when you run a Spark job, how are these partitions created? Then these partitions also have a relation with the number of CPU cores you're assigning. When you run the Spark job, you assign some parameters as well, right? Like number of cores it will contain and how much memory you are giving. So these are also creating the number of partitions. So there's a relation. Just go through that part as well once. Okay. Okay, I'll share a Google Doc link with you.
Sure.
Just see if you are able to access that.
Okay. Yeah, I can access it. It's empty, right?
Yeah,
Yeah.
I'll paste. Okay. Okay, one more question before that. So you said you have used Databricks, right?
Mm.
So what is the runtime for Databricks that you have used?
Mm. What is the runtime means?
There's some configurations, right, for
Mm.
using that, what cluster you will use, and there are some parameters also to be set. So what is that you have used or that is already assigned before project?
Yeah, yeah. It's to, as I mean, those things is to configured by the DevOps people
Okay.
previously. So yeah.
Okay. Okay. So we'll just cover Python first. Okay.
Mm.
So can you tell me the difference between deep copy and shallow copy?
No, no, I don't know that part.
Can just try. It's related to copy only. Just see if you can relate. When you, let's say, in terms of list, you can copy a list from another list, right?
Mm.
Using dot copy. So runs anything?
Just a second. So deep copy is like shallow copy is like it constructs a new compound object and then inserts references into that objects found in the original.
Okay.
And deep copy constructs a new compound object and then recursively inserts copies into that object found in the original. Like that.
So what is the difference? Like what is shallow copy doing and what is deep copy doing? Because both are copying objects.
Mhm.
But what is the exact difference? In shallow copy, as you understand from the name itself, right? As in shallow copy, it basically copies the references, not the exact objects. Okay.
Mhm.
Deep copy means deep, just try to relate to the English word only. It
Mhm.
deeply copies, so it is copying everything. Okay.
Okay.
Have you worked on pandas?
Yes, little bit.
Okay. Can you tell me the difference between a series and a data frame?
Uh, s- Series means like as a list you're talking.
There's a concept in pandas called series and data frame.
So exactly, I haven't worked in series, but what I can understand from the name is like it's a combination of lists, two lists. I mean, maybe for an example, let me
What is
type.
a data frame in pandas?
So data frame is a view of the data basically.
In the
So
tabular format,
in a tabular form, it is.
right? Series is the columnar thing. Like one column, it refers to
Mm,
a series. And data frame is the whole table.
mm, okay.
Okay, I'll give you a Python code to solve.
Okay.
It's an easy one. I'll write, okay, can you share your screen?
Sure. Yes. Okay. Pasted the.
You will see it on in the doc itself.
Just a second. I how to share this screen?
In the bottom, see, there's a share screen option in the Zoom link only. I mean, Zoom ID only.
No, I'm not getting that option.
In the bottom, mute, stop video, security, share screen.
Okay. Yeah. Okay. I think it's actually it's asking for access.
Yeah, just try
Uh,
now.
No, it's asking for system access. Yeah, actually, I'm using my office laptop.
Oh, okay.
It's asking me to quit and reopen.
Okay, the link, right?
Yeah, no, I mean Zoom is asking me to
You have to
quit.
rejoin.
Yeah.
Yeah, you can do that.
Let me try again. Let me try without doing that.
Yeah, I
Yeah,
can see your screen.
yes, yeah.
Yeah. Okay. So, yeah, this is the question. Just write a function and it should show like the result should be like that.
Create a function with two strings and return true if both words begin with same letter.
Okay, 1 second. You cannot edit?
No, I can.
Can you check now?
I think I can. Yes. So, Okay, is it just a one string or two different strings?
Two-word string.
Okay, so just a one string I'm taking as input, right?
That is up to you. It will be a two-word string. Like you can see crazy chocolate, lazy dog, like that.
Mhm. Can you tell me that how I can check if the starting letter is like a C or I mean the character?
No, you have to check basically that if it begins with the same letter or not.
Yeah, right. So I need to check the first starting letter, like percentage D
Yes, you
or
have to
something.
use indexing. You have to
Okay.
use indexing in this string.
Uh, so
And I don't think you need a loop for this. Anyway, try it.
mm, yeah, so index means like what's the right at index zero, right? Like that.
Yeah.
Is equals to- So yeah, so don't- so split. So if we split, there will be two words, right?
Mm.
So I need a loop anyway, right? So how can I check the first letter? So I need to check
You
for
need to
each.
use double indexes for that.
Okay, so 0 0 and 1 0, right?
Okay, I understand. Let's not
Mm,
think about the syntax. Can you
mm.
explain to me? So you have used, first you have taken a string, and where's the parameter inside your function? When you
Yeah,
call the function,
just
hmm, okay, just work on the syntax after the interview.
sure.
Okay, so you're splitting it
Yeah,
based on the
splitting is
space.
based on space, yeah, and then taking the first index of the first word and first index of the second word and
Okay,
comparing
now
it.
tell me one thing. Okay,
Mm,
so over here, if I take the example of crazy chocolate, right? Now
mm.
let's say the C of chocolate is in small letters. So will it match? One is in upper, one is in small. So will it return true?
Uh, mm. No,
You have
first of all,
to
here
you
it
have
is
to
both.
convert this into lower actually. Then do the
Okay, so
comparison.
yeah, so then we need to use the upper function. Yeah, maybe you can upper or lower convert
Lower,
both.
yes. So basically what you need to do is that if words, then 0 0 dot
Mm,
lower. This you I think you are missing, I mean confusing with SQL syntax. In Python it's dot lower afterwards.
okay.
Okay, so just work on the syntax once. Syntax doesn't look much correct, but
Mm,
the concept wise, yeah, I need to first convert into lower and then yeah, 0 0 first letter first word first letter, second letter second word first letter. That you need to
mm.
check. Okay, just work on the syntax. That's a feedback. Okay.
Sure. Yeah.
Okay. I'll quickly cover SQL as we are a bit out of time. So okay, I'll give you a scenario over here itself. So let's say you know case statement, right? Let's say you
Mm.
have one second. Case when 2 equal to null, then true, else false. When null equal to null, then true, else false. When 1 equal to null, then true, else false. So there are 3 scenarios, 3 when conditions. What will be the output of each of them?
It will be one output, right? So it will
No,
like
I forgot the commas. So this is one statement, this is one
okay,
statement, this is one
okay,
statement.
okay. Three different statements. Okay.
Yes.
Uh, so when two equals to nulls, then true is false. So here it is not comparing; it's assigning the value, right?
It's an
Uh,
equal to sign.
okay. I mean, equals to means is okay. It's equal, right? So yeah, it's comparing. So for two equals to null, the output will be false. So two is not equals to null. So the output will be false. So it will convert to uh, uh, true, false to true, then it's false. So first it will be false only. And null equals to true is false. It will give true, and it will give false.
Okay, this is your final answer?
Uh, I'm not sure if correct me if I'm wrong.
Oh, yeah, this is the catch over here. This was a trick question.
Hmm.
So we cannot compare null in SQL to anything. That is, so
Okay,
everything will be false.
okay, okay, okay,
Okay, null comparison is not allowed in SQL.
okay,
Okay. You can even, if you have, some MySQL or anything, just you will, when you run it, you will see that.
okay, sure. I'll do that.
Okay, one last question is, what is the difference between rank, dense rank, and row number? And explain just with an example. Let's say I'll just give you a data set, like let's say name, age, salary, a 21, business, a 20, okay, so explain rank, dense rank, and row number. That how will it work?
Okay, so what will be the partition here? Partition by name or age, whatever.
Yeah, that
Okay,
doesn't
so
matter here. Just tell me that considering partitions and order by everything, let's say that is done. Just tell me that how will it assign the ranks?
yeah, so for rank, it will be like so rank over partition by
I
let's
don't
say
want the
part.
syntax. Just that
Okay.
how it will assign the rank.
Yeah, so rank based on the order. Like if you're ordering by salary, then it will order. I mean, give the rank for each salary it will give. And like so for first of all row number, it will be 1, 2, 3, 4. So it will assign a row based on if you're
Got it?
giving order, then so, and then it comes rank. So let's assume we are giving a rank based on salary. So salary, it will give rank as 1, 1, and this is 2, and this is 3.
Mhm. So rank, okay.
And then comes dense rank. So for dense rank, we need to give a partition. So let's say partition by name or age. So you can see here all the ages different. So all the ranks will be 1.
No, dense rank also, let's say it has the same condition as rank only. Let's say partition by, let's say partition by age, order by salary.
Uh,
So what
for
is the,
dense
there's
rank,
a
right?
difference, yeah, there's a difference, basic difference between rank and dense rank.
Uh,
Okay, so
I
think
think
you.
for dense rank it will be like if you're giving same condition, then it will be 1, 2, and then here it will be 3.
You just need to, I think, brush up it a little
No.
bit more. Yeah. So rank, when the rank, what it does is when it has ties over here, right? It is a 60,
Mm-hmm.
60 is a tie. So 1, 1, it's fine, but it skips the next rank. So this will be 3 and this will be 4. It
Oh,
skips
okay.
number 2 because it has assigned same values to 2 of them. Dense
Mm.
rank solves this problem. It gives same number, but it does not skip anything.
Okay. Yeah.
Okay. Just go through these concepts also, and
Mm.
also practice window functions. Okay, so we are good with the interview.